Hi, my name is Remus and my ZID is Z5615941. Let's begin with how galaxies form and evolve. Galaxies form from the gravitation collapse of gas inside the dark matter halos in the early universe. As time passes, they grow and transform through star formation, gas accretion, and mergers. To make sense of these changes, astronomers use the Hubbard-Unifox classification that ellipticals are smooth and old, spirals are gas-rich and actively forming stars, lenticulars are disks without arms, and irregulars are chaotic, often shaped by interactions. Understanding of galaxies' morphology helps us decode its history and environmental influences. Next, let's look at what galaxy's color can reveal about its life cycle. One of the clearest indicators of a galaxy's activity is its color. Spirous galaxies are typically blue, which reflects ongoing star formation and the presence of hot young stars. These galaxies tend to be found in less dense environments where gas is still abundant. In contrast, elliptical galaxies appear red or yellow with little or no new star formation. Their stars are older and they often reside in dense clusters where gas has long been used up or stripped away. With these spirals, we also notice that the bulge is redder than the disk, meaning the center holder older than the stars, while new ones are still forming farther out. So blue galaxies are young and active, while red galaxies are old and passive. This galaxy system has undergone a major interaction, and we can see dramatic distortions along with bright blue patches. These blue regions signal recent star formation triggered when the gravitational forces of the collision compressed gas clouds. NGC 6745 shows us that galaxy mergers can reignite star formation even in galaxies that may have been previously dormant. The environment plays a direct role in reshaping galaxies. I classified 20 galaxies, each from 3 galaxy clusters ES, O, A, B, and C, as well as from the Hubble Ultra Deep Field. Here's what I found. And the clusters are dominated by ellipticals, which is expected in dense environments where frequent mergers lead to star formation shooting down. In contrast, the HUDF contains more spiral and irregulars, consistent with what we'd expect in the early universe. Galaxies that are still forming and evolving. Cluster galaxies are older and more structured, mostly red ellipticals. HUDF galaxies are bluer and more irregular and show signs of ongoing formation. So what might happen if we could revisit the HUDF in 10 billion years? Many of those irregulars would likely evolve into spirals or ellipticals through measures and the gradual shutdown of star formation. The overall population would be rather more passive and more structured. Through this experiment, I gained insight into how galaxies evolve and how structures and color reflect their age and activity. I also saw how citizen science like Galaxy Zoo allow the public to contribute meaningfully to real astronomical research. It made me realize that even images can serve as time machines, showing us galaxies as different stages of life. Galaxy classification is more than just categorizing shapes. It's about reading the stories written in starlight, how galaxies grow, interact, and transform across billions of years. So from chaotic irregulars to elegant spirals and massive ellipticals, every galaxy tells parts of the universe history. Thank you for listening.